Yeah, thank you for the introduction. I don't, obviously it's a rather huge subject to be able to encompass in 30 to 40 minutes. Might be a bit like ambitious, maybe a little bit longer. We'll see how we get on, but I think even just a discussion on dialectical materialism, the essential propositions of Marxist philosophy could take us well over an hour. You know, we could spend all day talking about it, and even within any individual field of science, we could talk about how dialectical materialism finds itself confirmed, if you like, through the discovery of the processes of nature. Now, Marx and Engels, of course, regarded themselves as scientific socialists, and they did not regard there as being any, if you like, artificial boundary between human society and the rest of nature. All that, for materialists, of course, all that exists, if you like, is matter in motion. And therefore, it's inevitable, if you like, that if all that exists is matter in motion, and therefore we can describe the world in quantitative aspects of velocity, position, and so forth, all of the qualitative aspects of the world around us, if you like, color, texture, these sort of things, all can be fundamentally reduced to the quantitative relationships and interrelationships of matter, which is fundamentally in motion. Now, I can't go into a full description of what dialectical materialism is. There's many sessions on like what is dialectics, the history of philosophy and so forth, and dialectics applied, as Stephen said, to different aspects of history and so forth. So I can't go into a full description of dialectical materialism, but I think it would be amiss to start a discussion like this without actually going into a bit of a little bit into what is dialectical materialism. So I think, just if I could sum it up in one sentence, I'd probably use the phrase by the aphorism by Heraclitus, the ancient Greek philosopher, who said that everything both is and is not, for everything is in flux. Everything is constantly in a state of change. Now, just taking this on the basis of common sense, someone might object to me quite rightly that, well, how can something both be and not be, if you like? This table very much is, and it is a table, and it doesn't seem to be in flux. It is solid, and therefore it's able to support my laptop, that can of Coke and so forth. It seems like, of course, not everything is constantly in flux. There is stasis and there is equilibrium within nature, and that is a fact. It would be an acid trip of an existence where everything in flux all of the time, and there is no such thing as stasis and equilibrium in nature. But of course, within the sciences, the whole essence of all of the sciences is to be able to explain the particular equilibria that arise, as well as to explain the changes, the discontinuities in nature and so forth. And I would push back on someone that says, like, this table seems completely solid. No matter how long I look at it, it doesn't seem fluid and changing. If you look at it on the microscopic level, of course, even a piece of furniture like this, you'll see it's constantly interacting with the environment. It's absorbing moisture from the atmosphere. There will be fungi and microorganisms which will be breaking it down. There will be, for every time someone puts something on this table, microscopic stresses will be opening up, and eventually those quantitative changes, if you like, will lead to a qualitative transformation. The table will collapse, or more likely it will be thrown away before it gets to that stage or something. A quantity transforms into quality. What appears at first sight as being completely static and unchanging, on further investigation proves to be in a constant process of change. All that is static and in equilibrium is relative, and we have to define the limits of the sort of relativity of that equilibrium, if you like, throughout all of the sciences. It requires explanation. Now, if this table was to break down, it doesn't have wooden legs, but say it lost a wooden leg and it did have wooden legs, so just forget suspend reality, if you like, for a moment, and I was to replace one of the legs or something on this table, then I think I would be well within my rights to say, is that now the same table? And there is no simple answer. Yes, it is the same table, and no, it is not the same table, because it is constantly in a process of change. I don't know, I apologise for the European visitors here if no one has seen Only Fools and Horses. It's a very funny sitcom, but there's one character in it showing the sort of the contempt, if you like, for manual labour that exists within society at large and within the sciences. There is a street sweeper who is naturally stupid called Trigger, and he jokes to his companions, if you like, that he's had the same broom for 20 years. And they look at him in amazement. How can you have the same broom for 20 years? He says it's had 5 new heads and 10 new handles. And they look at him like he's an idiot, like, oh, it's not the same broom, obviously, because you've replaced every piece in it. I prefer to think he's actually has a firmer grasp of dialectics than his semi-lumpen, semi-petty bourgeois friends, if you like, that he's trying to bring some sort of Marxist education to them, if you like. But there is, things are constantly in a process of change. Let's look at it upon further investigation. If we go into this table, if I say, what is this table? Someone could say to me, it is, it's molecules. There are atoms, protons, electrons, and neutrons. They make up molecules. They are in chemical affinity with each other. They make up cellulose molecules, which in life, when it was a tree, would have made up the structure of the cell. And over many cells, you would have had the bulk properties of the wood, which gives this the bulk properties of a table. It's able to support my laptop, for example. And that is a perfectly reasonable and correct and valid description of what the table is from a bottom-up perspective, if you like. But then somewhat I might equally object, and quite validly say that no, that's not what the table is. The table was conceived by a carpenter or an engineer or someone like that, and they conceived it in their minds first. They got a piece of wood. They exist in an economic system. The whole of society is organised so that they are fed and clothed and so forth, and they go down the supply chain to get a piece of wood sourced, and a tree is chopped down. Now, if that tree hadn't been chopped down, but the one next to it had been chopped down, or that tree had died because of some fungal disease early on in its existence, and another tree had been chopped down and transported to that particular factory or what have you, and that was planed into a tree. For all intents and purposes, this would be an identical table. That would, the table itself also has a top-down explanation as well as this bottom-up explanation. Both are equally valid, and for us, dialectics is understanding things not as static things taken in isolation, but understanding the relationships between apparently contradictory, if you like, concepts, the general and the particular, the unity of the accidental and the necessity, that this is made of these particular atoms is entirely an accident, that one of those trees was chopped down, turned into a table. It could have been another one, if you like. That all of these, the part and the whole, there is a constant interrelationship of matter, if you like. And we understand things in their interrelationships and in their contradictions and in their evolution. We do not break things down, if you like, into that is the essence of the dialectical method. Now, someone might then say, okay, now you've explained the dialectical method in excessive depth through this table, if you like. Well, what you say isn't particularly very profound at all. Actually, that's common sense. That's entirely common sense. And I might grant you that is common sense, if you like. But if as the saying goes, common sense is not so common quite often. And we find that there are extremely undialectical attitudes abound within society. We've all come across it. That confounding argument that cuts you down mid-flow, if you like, as a socialist. Well, your ideas all sound very good, but human nature, like just 2 words that cut down an argument, and you may as well just give up human nature. And we've all come across it. And what is not expressed in 2 words, what is not explicitly made explicit, is there is a deep set philosophical point of view that is expressed in those 2 words. Namely, that there is a human nature which is completely static and unchanging, irrespective of if you like, the tens of thousands of years of human society, that human nature is essentially static, if you like. And furthermore, it actually expresses a lot more than that. It expresses something, that is not a comment about society, that is a comment about science, that is a comment about our biology, that is a scientific judgment, and it has its scientific theorists. There are theorists who say that our human nature is essentially unchanging, that the entire field of sociobiology, with eminent scientists like E.O. Wilson, reduce our social organism, if you like, our social setup, to what is fundamentally our own characteristics as the phenotype, as the expression of our genes, if you like, and that we simply are selfish because our genes are selfish replicators looking to replicate their existence, if you like. That, again, it expresses a very reductionist, bottom-up explanation of human nature, because we see greed within society, we see profiteering and avarice and a warlike nature within society, this society, capitalism, that this is the direct correspondence to our own human characteristics, that society is nothing more than the sum of its parts. It is a profoundly undialectical view, and that we presumably are nothing more than an expression of our genes in a very mechanistic one-to-one relationship, if you like. It expresses a lot of philosophical baggage, which is not conscious, but which is unconsciously imbibed from the society around us. That is the importance of dialectics. We can see that, that was a scientific opinion. That was a scientific opinion which expresses a well-known social bias, well-known social, if you like, prejudice that comes from capitalism. That it is capitalism which is unchanging. It's worthless. Give it, you may as well give up, if you like. But we can see there is a dialectical relationship between science and society. Science itself is merely a set of material relationships and, if you like, intellectual relationships within a context of human society. It also evolves in a dialectical manner. And so I'd like to let's start by placing science in its historical context, I think. Let's begin by actually looking at how we as human beings develop science and how it interacts with philosophy and the rest of society. Now, I mentioned Heraclitus, and I think that's a good place to begin, with the ancient Greeks. Dialectics has a history which is much older than the ancient Greeks, of course. You can find elements of dialectics in Taoist philosophy and Buddhist philosophy. All over the world there have been independent developments of if you like, dialectical philosophy. But I think the ancient Greeks really, certainly in Western European tradition, developed philosophy to an extremely high degree, if you like. The discoveries of the ancient Greeks were not matched in Europe, at least, until the period of the Renaissance. And even then, to be honest, a lot of the discoveries of the ancient Greeks in dialectics, in philosophy and in science, if not in the particulars, if they were invalidated in the particulars and the like, in the general actually maintained a lot of their validity against far later thinkers who had the benefit of all of the advances of not just ancient Greek thought, but also much of the Renaissance thought, if you like. I don't have time to go into the full depth of the richness of ancient Greek philosophy, if you like. I think there is a session on it at some point over the course of this weekend. But just to give a few examples, the ancient Greeks developed a theory of evolution with very little, if you like, material means to actually investigate the theory of evolution. They didn't have access to all different species that, if you like, Darwin had after his voyage on the Beagle. They had Anaximander, I believe it was, who discovered a certain theory of evolution, that we are descended from some sort of fish and amphibian-like creatures, merely had the access to the human embryos, and if you like, and a certain amount of ingenuity and guesswork on his part. We have a theory of atomism, which is probably one of the greatest achievements of the ancient Greeks. And when you read the atomistic writings of people like Lucretius, the ancient Roman philosopher, you see there is a certain naivety, childlike naivety, but there is also a glint of brilliance in these writings, if you like. They achieved all of this, and they achieved it in spite of the low level of technological development. In fact, what is remarkable is there is almost no connection between the tremendous intellectual feats of the ancient Greeks and the material conditions around them. It didn't advance, if you like, industry or productivity. Quite the contrary. The slave system proved to be very regressive at a certain point, precisely because you could not actually apply the developments in philosophy and science and so forth to ever more finer techniques, because of the limits of the slave system itself. It relied upon a revolution in the economic and social conditions to carry that forward. And of course we know that the ancient Greek philosophy was based upon, and the achievements of ancient Greek science as well, or natural philosophy, was based upon the slave mode of existence. In other words, these people could only think and philosophize and come up with scientific concepts on the basis of the fact that they were fed, they were clothed, they were housed by the slaves. These, and eventually, of course, we have mental labor and philosophizing are raised to something far more noble than mere manual labor, if you like. It was the privilege of a ruling class. As much science and philosophical thought has been throughout history. And if we, obviously, as I say, this wasn't able to take society forward. Society didn't move forward in spite of these tremendous achievements. Eventually, it arrived at an impasse, and of course, we have the collapse of classical ancient civilizations. And what stands out is a period almost of like a writer's block lasting centuries. Between the Renaissance and ancient Greece, you have to ask yourself, why was so much of Greek philosophy and Roman philosophy to a certain extent completely forgotten by the peoples of Europe in the Middle Ages? It was preserved by the Arabs and other peoples, if you like, but within Europe there was a complete backsliding. We forgot all of this achievements of philosophy. Much of it was still preserved, it still existed, particularly some of Aristotle's ideas and Plato's ideas formed the basis of the dogma of the Catholic Church. You know, there was an injection of ancient Greek philosophy into the ideology of the feudal epoch. But why does it seem, I mean, if we had the great men view of history, we must take the view that presumably there was just a dearth of geniuses like in this period, essentially. I don't believe that is the case. Actually, you have outstanding geniuses in the Middle Ages. One quite noteworthy example is a man called Nicole Dorem, who was a French, he was a French clergyman of, I think, the 14th century, and he made some remarkable discoveries. He studied Aristotle and Plato's writings, in particular the physics of Aristotle, and he came to conclusions with regard to mass and inertia, which in many respects resembled the ideas of Newton 400 years later. Yet we don't talk about Dorem's first law of mechanics, we talk about Newton's first law. Why is that? There is 400 years separating them, and there is 400 years of social progress, social change that took place, if you like, within that period. His writings were merely essentially dismissed as very interesting commentaries on the writings of Aristotle and so forth, on ancient Greek philosophy. But fundamentally, the dogma of the Catholic Church dictated what was allowed, if you like. To quote St. Thomas Aquinas, philosophy, and therefore also natural philosophy, was merely the handmaiden of theology. Thought, if you like, abstract thought, theoretical thought, was the monopoly of the ruling class, and the ruling class were fundamentally linked to landed property and also to the spiritual and temporal dictatorship of the Catholic Church, which justified this feudal system throughout the Middle Ages. So there were tremendous thinkers and geniuses, but all of that thought was subordinated to the class interests of the ruling class. What was necessary was a revolutionary class to come along to liberate that, if you like, philosophy and natural philosophy from the spiritual dictatorship, from the position of being a mere handmaiden of theology, and turn it into a revolutionary weapon against the old feudal elites. And of course we know that happened in the period roughly equivalent with the Renaissance and with the Reformation. There were some great thinkers who did come along and, if you like, liberated science, if you like, from the spiritual dictatorship of the Catholic Church. And not only the Catholic Church, indeed, also the persecutions of the Protestant Church as well, and religion. And that class, of course, was the bourgeoisie. And one of the first, if you like, revolutionaries within science to turn it literally into a weapon against the old ideology of the feudal epoch was Copernicus, Nicholas Copernicus, the Polish astronomer, who literally shattered the crystal spheres of the heavens, if you like. The whole cosmology of the Middle Ages, which was based on the ideas of a guy called Ptolemy, who was a Roman cosmologist, was based upon essentially the theoretical justification of the feudal order. We have the Earth at the center of the universe, and the Earth is the center, of course, of God's creation. Everything is imperfect on it, but it is fundamentally it's where we live as the highest point in God's creation. And beyond the Earth, you have the various spheres of the moon, of the planets, and of the stars. And they've completely forgotten everything about ancient atomism. In fact, Epicurus was completely denigrated as being in favour of some sort of hedonist materialism, if you like. These spheres were made of perfect crystalline substance, of course, because God is perfect and that's where God lives. And they were rotating around the Earth at the most dramatic speeds. Of course, the sphere of the stars was rotating at the most absurd speeds of all, because that was where God lived. There was only one being in existence which could move these spheres at quite an outstanding rate, if you like. And yet Copernicus completely overthrew this. Why was this? I highly recommend two books by a guy called Thomas Kuhn, if anyone's familiar with his writings. A book called The Scientific Revolution, where he lays out his classic idea of the scientific revolution, of the overthrow of one paradigm by revolutionary science and its replacement by a new paradigm. A much overused term, this idea of a paradigm shift. It's been much used and abused, but I also recommend a book by by Thomas Kuhn called The Copernican Revolution, where he studies this in a lot of depth. And what you see actually, something he doesn't make explicit, is that the revolution in science was not something which took place outside of the conditions in the rest of society. Why was the old worldview overturned? For a period of time, it actually proved to be the most scientific and reasonable way of viewing cosmology. After all, if the Earth moves, why can't we feel it move? You know, why isn't the atmosphere completely blown off the Earth if the Earth is constantly in motion? It successfully explains the motions of the stars and the moon and the sun to a certain extent, if you like. And yet it was beginning to enter into crisis, and entered into crisis centuries before Copernicus came along. New observations were throwing up discrepancies, particularly with the motions of the planets in particular. They don't follow a simple circular motion. In fact, they had to develop mathematical models which became more and more complex and cumbersome, which was an illustration of a cosmology in crisis. I can think of some parallels in the modern day with the different things that are added on to justify our current cosmology, if you like. These epicycles and epicentrics, suddenly you had spirograph motion. It wasn't the simple motion which this nice Ptolemaic theory had laid out previously. It was a far more complex, and it was in crisis. It was clear it was in crisis, and it had been for centuries before Copernicus came along. But it wasn't new observations which overthrew the old, if you like. This was Thomas Kuhn's idea, that normally science is conducted in the context of a paradigm. There is a worldview, if you like, which forms the normal way that science is conducted. We expand upon that worldview. We do observations which confirm it, or in some way, or extend it to a new sphere where it hasn't previously been applied. There were more and more measurements on the basis of this Ptolemaic view of the universe, but it wasn't measurements themselves which suddenly weighed upon the old theoretical conception. Actually, the telescope, as we understand it, the telescope wasn't developed until 50 years after the death of Copernicus. It was the change in the social conditions. The old Ptolemaic view of the universe was a key prop in the cosmology of the feudal epoch. It was the revolutionary bourgeoisie who took possession of science and cosmology and turned it against the old feudal elites, if you like. And within that Copernican revolution, there are periods of counter-revolution, and there are steps back immediately after Copernicus's death, and again step forward. But eventually this forms, through Galileo, through Kepler, and with Newton, it forms a complete worldview, if you like. It gains a certain amount of perfection. It becomes a new paradigm, which through the scientific revolution has overthrown the old paradigm. And with Newton, we have a real revolution within physics. Because Newton, for the first time in his theory of the general theory of gravitation, unifies the physics that we see here down on Earth with the physics which takes place in the heavens. Now, I don't think it was any coincidence that the scientific revolution first took place in the sphere of astronomy and cosmology, because it's so you can study the very predictable motions and theorize about them. Things are very different down here on Earth. Things don't follow simple repeating patterns. You can't get away from dialectics when you study how things actually evolve down here on Earth. People are born, they live, and they die in that order. That things are much more mortal, if you like. It was no coincidence that the immortal heavens were the sphere where God lived, because it seems that nothing changes, or if it does change, it changes in a very regular, very mechanical, and very predictable sort of way. Down here on Earth, even the simplest chemical reaction, like boiling an egg, is an irreversible process. You cannot ditch dialectics when you begin to introduce science to the study of the world around us. And of course, Newton unified the physics of the heavens with the physics of the Earth. The irony, of course, is that Newton had absolutely no interest in philosophy. The philosophical implications of the Newton's revolution in physics eventually would lead to the introduction of dialectics to the heavens, if you like. But that wasn't Newton's philosophical outlook. He had a complete contempt for philosophy, summed up in his quote from the Principia, that physics beware of metaphysics, physics beware of philosophy, in other words, was what he was essentially trying to say. How are we doing for time?
About 25.
Oh, okay. It was... he had Indeed, he had no interest in physics whatsoever. The irony is that he was a complete slave to one of the predominant philosophical theories which was arising in this period of time. That is the philosophy of mechanical materialism. We see that Newton's theories fed into that philosophy, and he also himself adopted essentially that worldview of an essentially clockwork universe where the world is separated into its isolated particles. And if we could just simply understand where the position and velocity of everything is, we could predict the whole. Like a piece of clockwork, we could predict the whole unraveling of the universe for all eternity. That was Laplace's conclusion from Newtonian physics. And Newton himself he was himself a religious man, and he believed that if we could just, all that was necessary was a first impulse by God, and everything would continue along its motions for all eternity. In other words, it was very much a mechanical materialism. Everything broken down into its parts, which are essentially seen in isolation, rather than seen in their interconnections, if you like, obeying completely ahistorical laws of motion. And indeed, Newton's laws, when considered on their own, do not tell us anything about the way the world is going to evolve. There is no direction of time, if you like, in Newton's laws, for example. And that had a tremendous importance for the development of also of philosophy. We see that the period that we're talking about is also the period of mechanical materialism, which from people like Francis Bacon and John Locke led to a conception of materialism where we are ourselves also essentially nothing but complex mechanisms, and we passively interact with the world around us. That motion, that matter interacts with us in a very mechanical way, and we only have the sense perceptions of the world around us through which we actually we can tell something about the world itself, if you like, that we cannot know the thing in itself. This is from actually the limits of mechanical materialism. We see a descent into subjective idealism with people like David Hume and Bishop Berkeley directly drawing upon the weaknesses, if you like, within mechanical materialism. And it's actually no coincidence that the first attempts to introduce dialectics into the cosmology was by Immanuel Kant, whose theory of the nebula hypothesis was rejected in many respects right up until the 20th century, where he talked about the idea of, if you like, the solar system itself has a history and an evolution. But anyway, I'll come back down to earth for a second, if that's all right. As I say, you cannot simply, particularly when we're talking about the more like worldly science, if you like, down here, away from the sort of cosmology, you cannot simply ditch dialectics. Everything is changing. Everything is in a constant state of evolution. And indeed, that term evolution is very much connected with one name within the sciences, but it fits in with an entire philosophy and worldview within science that was developing at the end of the 18th century and the turn of the 19th century, which touched upon not just biology with Darwin, of course, but also upon geology and other areas of the sciences. And Darwin's discovery was essentially the discovery that dialectics operates within biology, and he didn't actually invent the theory of evolution. That's one thing that I think has to be pointed out. To Darwin, we don't owe evolution. Everyone knew that species and creatures evolved down their lineages. Of course, like amongst dogs, we have like some of the most monstrous examples on some occasions of what human selection, if you like, can do. We know that there is, if you like, this quantitative change generation from generation. We can see that around us. That was entirely known, those quantitative changes. What the revolution that Darwin undertook was to link those quantitative changes to the qualitative transformations between species, to see that in the natural variation, which was well known and well understood, that we see around us, lays the basis and the potential for the qualitative transformations between species, the emergence of one species out of another through descent and through natural selection. And this was essentially the introduction of dialectics into the field of biology, for which, of course, Marx and Engels were tremendously enthusiastic about the ideas of Darwin, but he fit into a much broader intellectual, if you like, tradition of evolutionism. We have also Charles Lyell, the geologist, who in many ways actually informed Darwin's views, developed a very similar theory, if you like, of the evolution of our geological landscapes. It's the quantitative processes which go on around us on a day-to-day basis, lay the if you like, the fundaments for the huge transformations we see in our geology. The process of sedimentation by rivers, the cutting of valleys by rivers, the volcanism, all of these sort of things. These small changes that take place on a day-to-day basis were well known and well understood. And it was also well known and understood prior to Charles Lyell that there are entire geological epochs which are separated from each other, that there are massive changes have been wrought in our surroundings. And the predominant theory previously was that something from the exterior had changed a fundamentally unchanging system. It was the theory of catastrophism, of, if you like, Noah's flood coming along every so often and completely changing the landscape. The geology would undergo a revolution, but not one that was inherent within the contradictions within the nature itself, if you like, but one which was essentially foisted upon nature by God or by something external, some external force, if you like. Lyell's theory of geology, of uniformitarianism, was essentially the introduction of dialectics to geology. And within Lyell, there are limitations. This change was, if you like, this evolution was perceived in a very gradualistic sense. As scientists, they were not immune from the philosophical prejudices of the society around them. They imbibed those prejudices, and both were, in Britain in the start of the 19th century, had a philosophy which was fundamentally that of bourgeois reformism. They had, in the case of Darwin, for example, he was directly inspired by the ideas of Malthus, of the principles of population, whereby we produce food at an increasing rate of resources are increased at an arithmetic rate, whereas population increases at a geometric rate, and therefore there is a struggle for existence, and there is, it is essentially unnatural, and therefore the wrong thing to do under bourgeois society to feed the poor. This was the theory of Malthus, if you like, and Darwin himself was directly inspired by that. And so if you like, the natural selection. Evolution by natural selection is perfectly correct. The interpretation which Charles Darwin gave it involved a whole load of philosophical baggage which came from the bourgeois society in the early 19th century, of the struggle for existence. It was the imposition upon nature of essentially laws of capitalism, if you like, of the law of the jungle within capitalism being applied to nature as if it takes place simply in that sort of way. And of course, with a bourgeoisie in Britain that has a revolutionary past but is keen to exercise that past, if you like, there is a theory that is dominant within society of like we say, of gradualism, of reformism, if you like, of slow change. Yes, change, but slow, gradual, non-catastrophic change was definitely on the order of the day. And we see that was very much a characteristic of Darwin's theory of evolution, of slow, gradual, percolating change. And if you look even at the start of the 20th century, of the tree of life, how it unravels, you'll see that these branches slowly sort of come apart from each other like this. There are no catastrophes, if you like. There is no stasis within nature. And Darwin was perturbed by the fact that there is a lot of evidence which doesn't really go into supporting that, particularly in the fossil record. He was very well aware that these sort of, if you expect slow, gradual change, you expect to see all of the intermediate links between one species and another as you have biological evolution. That is not the case. Nature is full of holes within the fossil record. These so-called missing links exist across all sorts of species, which is very easy to dismiss when we're talking about, for example, vertebrates, because when vertebrates are fossilized, they usually are fossilized in large groups where all of the bones get mixed up. You don't have full, complete skeletons. It's very easy to, if you like, it's very difficult to fossilize an organism, and it's very hard to find the complete samples, if you like, and specimens. These were regarded as genuine gaps. So it's, again, with the progress of normal science within the old paradigm of Darwinian gradualistic evolution, you instep individuals such as Stephen Jay Gould and Niles Eldredge in the 1970s, and tried to actually, let's find these gaps in the fossil record. And Niles Eldredge actually went out and was like, well, we can't find them amongst the vertebrates. Let's have a look amongst arthropods, for example, trilobites. And he went out and did a statistical study of trilobites, because they exist in their millions across entire geological epochs. They exist in all sorts of different continents and so forth. And he was
dumbfounded by the fact that when he looked across millions of years in all sorts of different areas, they all looked the same. All of these damn trilobites looked exactly the same as each other. He couldn't tell the difference. But then in other layers of rock from millions of years later, they all look completely different. And his conclusions were essentially that he had failed. This PhD has been a complete waste of time. May as well go home. That was his first conclusion. But that is interesting, actually, because that is how science progresses. A lot of the contradictions which develop within an old theory, within an old paradigm, at first are quite often dismissed as completely incorrect results, as false results, and can lead to the demoralization of scientists. As it was, Niles Eldredge and Stephen Jay Gould came up with a new theory which has proven to be spectacularly correct in what it actually, in the fact that nature does not develop along the other lines that Darwin conceived of it. In fact, there is no gradual change between species. For the most part, species remain in stasis. There is very little change, or rather what change does take place is not of a visible nature. And then there are very short periods in geological terms of radiation of species, of new species emerging, of qualitative transformations taking place within nature, i.e., according to the theory as it was called of punctuated equilibrium, you have species existing in equilibrium, but it's punctuated by periods of catastrophic change of new species emerging, such as in the Cambrian Revolution, where you had suddenly, for millions of years previously, all you had were these single-celled organisms, and suddenly an explosion of these multicellular complex organisms emerging. That nature transforms by the dialectical law of the transformation of quantity into quality. And this was and the modern genetics has magnificently actually confirmed this theory of, if you like, punctuated equilibrium by giving concrete examples of how individual quantitative genetic changes are necessary for a qualitative transformation of an organism. I can think of, there was a brilliant experiment in the 1980s on E. coli bacteria where they examined, if you like, hundreds of generations of E. coli bacteria in the laboratory, where you can see evolution taking place because the species the organisms replicate at such a rapid rate. And what they noticed was a sudden transformation in the E. coli. They started consuming a chemical which was placed in these Petri dishes, which wasn't meant to be consumed. They put some glucose in there as food, and then some pH stabilizer. And then suddenly they found one morning they woke up and these E. coli were eating this other chemical that wasn't meant to be eaten by E. coli bacteria. It was a complete transformation in the organism. It was a new domain that they had essentially broken out into. And they proved that what was necessary to get to that stage was a whole series of quantitative changes within the genetics of the E. coli. And the same thing has now been proven of quantity transforming into quality in across different organisms, if you like, for everything from stickleback fish through to bacteria. So you see that dialectics, if you like, in spite of the conservatism of the philosophy of the epoch, which denies dialectics in society, and we see how that reacts also upon dialectics in nature, if you like, how scientists themselves are human beings. They bring their philosophical prejudices to the science which they're actually investigating. But the uncovering, if you like, of the real dynamics within nature shows that nature abides by, if you like, the laws of dialectical materialism, that the progress of science is the progress of the discovery of these dialectical laws operating also within nature. And how could it be otherwise? As I said at the beginning, you know, all that exists is matter in motion, and therefore all that we can use to describe the qualitative transformations in nature are the quantitative relationships between matter, if you like, that position, velocity, mass, charge, these sort of things. But I think something that is important, and as we've demonstrated with the progress within science, there are steps forward, but there are also steps back. The general trend within human history is a trend towards an increasing, if you like, breadth of scientific knowledge, of a greater profundity of our understanding of nature, and greater control over nature itself. And yet that has not been without its steps backward. It is not a linear and it is not an automatic process. And we see that capitalism itself brings its own laws to bear upon the progress of science. It is one of the most dramatic aspects of capitalism is how far it penetrates into all spheres of human activity. The division of labour between mental and manual labour on the one hand, but within the sciences themselves, there is a necessity, if you like, to specialise within the sciences. Of course, there is that necessity. But the division of labour, if you like, carries that to an extreme. And we see within the science, I mean, I don't know if there are any scientists here, but there are biologists who will spend their entire life studying biochemistry. And, you know, it requires specialists. You know, they may know very little about anatomy. There are anatomists who will know very little about the complex behaviour of the folding of proteins within the cell. And it is natural that science should progress in that sort of way to some extent, but when taken to an extreme, as we understand, things can turn into their opposites. As Richard Lewontin said, and he was quoting from some other biologists, nature does not exist in its parts. You do not see heads and feet and hands and ribs in nature. You only see those under the knife of the anatomist. Within nature, there are only whole organisms that can only be fully understood in their interaction, if you like, with the rest of nature. That's not to say that, of course, that, as I said previously, breaking down things into their constituent parts is a necessary aspect of progress, if you like, of scientific progress, of understanding the dialectics within nature. For example, it would be impossible to imagine modern chemistry had, depending on who you believe, made this discovery, had oxygen not been isolated by either Joseph Priestley or the other, what's his name, Lavoisier. It's necessary to be able to isolate things into their parts to understand the quantitative relations between them, if you like. Nowhere in nature do we see native chlorine, or very rarely do you see native chlorine, if you like, and yet it's all around us in combination with sodium in table salt and so forth. It is necessary to break things down, and within physics, within chemistry, within all the sciences, we break things down, we take them out of nature, we rip the parts out of nature, and we study them in isolation, we study them in equilibrium. Let me just have a look. And yet, of course, when we put them back into the rest of nature, things behave very differently. Equilibrium, to the extent that they exist, are only temporary, whereas in the laboratory we can set boundary conditions to an ideal gas equation, for example, that everything is at standard room temperature and pressure. There is no standard room temperature and pressure within nature, if you like. There are no simple mathematical laws which will be able to describe nature in its full complexity. And we see that even when things achieve a very minor level of complexity. So, for example, with Newton's laws, which he thought of as, and Laplace and others thought of as giving a very simple description of the universe behaving in clockwork, if you like. If you have more than two bodies, if you have, say, three bodies in gravitational relationship with each other, in orbit of each other, what you see is you immediately generate a chaotic system. You cannot predict that no matter how hard you try, because if you place those three bodies in a slightly different position, the motion will be qualitatively different after just a few rotations, if you like, of these orbiting bodies. And the three-body problem presents one of the, if you like, it's one of the classic problems of Newtonian physics. You see chaos within nature, where the smallest quantitative change can lead to a complete qualitative transformation. We know this principally as the butterfly effect, of course, where a butterfly flaps its wing in one part of the world can lead to a hurricane in another part of the world. Irreducible complexity exists in nature, where things cannot be simply understood in terms of simple scientific laws. These remain abstractions, if you like. And we, of course, though, studying dynamic non-equilibrium systems is an extremely difficult task, and for the most part it has been completely intractable. We cannot give an accurate, if you like, description of how the three-body problem unravels. But with computers, with modern computing, we are able to finally begin modelling these complex systems, if you like, and giving them a mathematical description. And it's out of that, actually, which we've seen the development of modern chaos theory, of complexity theory, which has found remarkable patterns across the whole of whole number of different fields. with the, as I say, chaos being one of them, the idea that small changes, if you like, lead to complete qualitative transformations where the system after a few generations doesn't actually resemble itself. But we also have the opposite law, if you like, is also inherent within complex systems, dynamic non-equilibrium systems, where you see the emergence of extremely complex qualitative formations which are very much independent of the initial starting conditions. For example, the evolution of fins and flippers within all sorts of different organisms that started from very different starting conditions but converged on very similar qualitative conditions. And I highly recommend in this regard a book by Mark Buchanan called Ubiquity, which looks, if you like, at this, how dialectics has been rediscovered in chaos theory and complexity theory in the modern period. And I'd like to, I'll sum up now. So, as I said previously, I don't think that progress is inherent within science. We've seen periods of, I sometimes think that we do have the idea that maybe with all of the knowledge that has been accumulated from the ancient Greeks to the modern scientific revolutions, that we are in some way, there's no possibility that we can take a step back, if you like. There could be no return to a dark age in the modern period. But one thing I think that, I've pointed out now, and I think I want to re-emphasize, is that there is no separation between science and the rest of society. When society enters into crisis, we also see its reflection within the sciences itself. It's not immune to that. It is not an automatic process that science will go on advancing, if you like. And we see the elements of crises in the sciences at the moment. There was one scandal came out in the most recent period of how the sugar industry has basically blamed fats for the last few decades for the rise in heart disease, obesity, and these sort of things. The oil monopolies, when they try to pull that sort of thing with global warming, they've essentially been caught out. No one really buys that sort of, if you like, climate change denial. But the sugar monopolies have been getting away with it for years, essentially. We do still, intelligent people, thinking people, have bought into this sort of bad science, which has essentially been bent in the interests of capitalist monopolies. But beyond the obvious scandals, there are more insidious, more unconscious effects, if you like, of the capitalist crisis and how that affects the sciences. The dressing up of all sorts of once seemingly defunct philosophical ideas, of idealist conceptions, being revived with, to quote Lenin's phrase, all of the tinsel of modern science being churned out with a new form, if you like, such as the justification of idealist conceptions within quantum mechanics that we see with the Copenhagen interpretation. We see a philosophical crisis within science. Recently, there was a debate within Nature magazine over what is the scientific method. There are those amongst the theoretical physicists and mathematicians who believe that science doesn't have to necessarily have any relationship to experimental science, that the beauty, if you like, of the theory itself is sufficient justification for the theory. There is another crisis within science, is the reproducibility crisis, which has been stalking a number of scientific fields for a period. Within psychology has been deeply affected by it for decades. But I'll give you a quote from a neuroscience magazine that shows that it is not simply something that's affected to this or that field. It says, within a culture that pressures scientists to produce rather than discover, the outcome is a biased and impoverished science in which most published results are either unconfirmed genuine discoveries or unchallenged fallacies. This is a direct result of turning academics, academia, and scientists essentially into a sausage factory where they have to churn out more and more papers. It's a publish or die atmosphere. And science is the victim, if you like. But these crises are not going to unfold in a simple manner. There are going to be periods where we see a building up of pressures, of cuts and attacks and austerity, of the impoverishment of science through the forcing scientists to publish more and more papers irrespective of the quality, is going to eventually lead to a qualitative transformation. Crises within capitalism do not happen in a slow unfolding and predictable way. They reach a crisis point and a tipping point. And science itself, I think, is a battleground for the defence of the advances of the past. It is also a battleground for the defence of our ideas. We've seen in previous periods how science and philosophy can be used as weapons in the hands of one class in its bids to transform society and overthrow an old class. Likewise for us, the defence of the materialist method, which finds its highest confirmation within the dialectics of nature, if you like, is also the struggle to transform society itself. So I'll leave it there.